In this section, I'd like to explain the variation of parameters. So we consider the standard form of a linear second-order differential equations. In the last sessions, I explained how to discover a particular solutions by looking at the expressions of the gx. But in this case, sometimes we might have a problem to find out the trial functions, particular solutions. So variation parameters is a more standard method to find out the particular solutions. So I'd like to show you the variation parameter method to find the particular solutions. To find the particular solutions, at first we need to find the solutions of the associated homogeneous differential equations. Y2 prime plus px y prime plus qx y equals 0. We'd like to consider. Then find the solution of the homogeneous differential equation y sub 1x, y sub 2x. So solution is expressed of the homogeneous differential equations y equals c sub 1 y sub 1 plus c sub 2 y sub 2. If you consider the constant value of the c sub 1 and the c sub 2, then it becomes solution to the homogeneous differential equations. To find the particular solutions, we should explain the gx in the right-hand side of the equations. So instead of the constant parameter of the c sub 1 and c sub 2, you could consider the variation of the parameters. The u sub 1 and u sub 2 is a function of x. As a trial function of the particular solution of the y sub b is expressed as u sub 1 y sub 1 plus u sub 2 y sub 2. Then derivative of y sub b prime is expressed as u sub 1 prime y sub 1 plus u sub 1 y sub 1 prime plus u sub 2 prime y sub 2 plus u sub 2 y sub 2 primes. And the second derivative of the y sub p becomes u sub 1 2 prime y sub 1 plus 2 u sub 1 prime y sub 1 prime plus u sub 1 y sub 1 2 prime plus u sub 2 2 prime y sub 2 plus 2 u sub 2 prime y sub 2 prime plus u sub 2 y sub 2 2 prime. Then substitute these equations into the original differential equation. Then it becomes, this is the equation we obtained. It becomes y sub 1 2 prime plus p y sub 1 prime plus q y sub 1. And then y sub 1 and y sub 2 is a solution of the homogeneous differential equation. So this part becomes 0. Also y sub 2 2 prime plus p y sub 2 prime plus q y sub 2. This part is also 0. And the other term is combined to form the derivative of the u sub 1 prime y sub 1 plus u sub 2 prime y sub 2 plus p times u sub 1 prime y sub 1 plus u sub 2 prime y sub 2 plus u sub 1 prime y sub 1 prime plus u sub 2 prime y sub 2 prime equal g, the right hand side. Then finally we have these equations. We'd like to solve these differential equations, but the main object of this calculation is to find the particular solutions. And a further assumption for the u sub 1, u sub 2. Because these terms appears twice, so we consider this is 0. Then original equations becomes simplified to becomes this equation. Then u sub 1 and u sub 2 primes is expressed using these two equations. Then we could integrate both equations to find that this is from the u sub 1. From the equation on the left, you have an equation for the u sub 1. And from the right, you have a u sub 2. Once we have a u sub 1 and u sub 2, we could find the particular solutions, because the particular solution is expressed u sub 1 y sub 1 plus u sub 2 y sub 2. So using the variation parameter method, we could find a particular solutions. Once you have a particular solutions, general solution is a c sub 1 y sub 1 plus c sub 2 y sub 2 plus particular solution. This is a general solution. If you have a difficult time to find the form of the particular solutions, you should use a variation parameter to find a particular solutions. Then I'd like to show you another method to solve the non-homogeneous equations. So we consider the differential equation of the y2 prime plus 3y prime equal exponential minus 3x. So because of the right hand side non-zero function appears, so this is a non-homogeneous differential equations. Then if you use the differential operators, this is expressed capital D plus 3y equal exponential minus 3x. Then integrate 1 times. So integrate of the 1 time, it becomes a d plus 3y. And right hand side is a integrate. So integration of the exponential minus 3x it becomes minus 1 over 3 exponential minus 3x plus integration constant. This is the integration constant. Then as I explained, we multiply the exponential 3x because of this is positive 3, capital D plus positive 3y. As I explained, two terms combine into the single terms by moving the exponential terms to the inside of the derivatives. So capital D exponential 3xy equal minus 1 over 3 plus c sub 1 exponential 3x. Then integrate in the both sides of the equation. Integral of the minus 1 over 3 becomes minus 1 over 3x. C sub 1 exponential 3x. So it becomes c sub 1 over 3 exponential 3x. And another integration constant. Then dividing by the exponential 3x in the both sides of the equations, we have a general solution of the differential equations. In this section, I explained how to find a particular solution using the variation parameters. Okay, this is the end of this session.